Hello everyone. Welcome to our webinar today to talk about top 5 technology trends to watch in 2022 in India's solar sector. The event is organized by JMK Research, a market research and consulting firm focusing on renewables and e-mobility segments. The session today is supported by LONGi, a global leading manufacturer of high efficiency monocrystalline solar cells and modules, and Solis, a leading global manufacturer of string inverters. Quickly on the format of the webinar will consist of interactive discussion with an eminent speaker, followed by question and answer session. At the end, we will have 15 minutes for Q&A round, in which we take questions from the attendees. Participants are welcome to submit their questions in the Q&A box at the bottom of the webinar window, and I request my panelists to answer them in parallel in the live session. Some of the key discussion points for today's session are to talk about the emerging technology trends in string and central inverters, understand new module technology trends that will shape India's solar sector, what will be the role of trackers in new installations going forward, technology roadmap plan for domestic manufacturers, and role of PLI scheme. And now to take on the discussions today, we have a very diverse mix of industry experts with us today. A quick intro of our experts here today. We have Mr. Pavan Mathur, Technical Leader, LONGi. We have Mr. Idrish Khan with us, Chief Technology Officer from Solis. We have Mr. Amresh Mahajan, Head of Technology, O2 Power. Next, we have Mr. Goutam Samanta, Head PV Technology from Juniper Green Energy. And lastly, we have Mr. Rama Lingeswara Prasad, Head Proposals, Renewable Business Unit, L&T Construction. Thank you all to be part of this discussion today. Welcome to the session. We would now like to start with Idrish, you first to share some insights on new technology trends across central and string inverters that you foresee in India market going forward. And how are these trends going to benefit the developers? Over to you,
Thank you,
Idrish.
Jyoti. Thank you, Jyoti. Very good afternoon to all my co-panelists and attendees. Thank you, JMK, for having me here on this forum for the discussion. As I'm representing Solis, we are the leading string inverter manufacturer globally. So, like keeping a focus on solar inverters are like a very hot topic for every project, either it is a smaller project or a bigger project. So, and we see that in last 1 decade, there are a lot of improvement has happened in last 10 years about talking about a small capacity inverters or now going toward high capacity inverter in central on string inverter. At the same, on the same trend, it is been followed continuously and keeping a focus like string inverter developments are more supporting more are very close to the trend which has been demand in the market. More or less the compatibility is the major criteria to find that which product or which inverter is supposed to be able to fit in the particular size or particular project. So on the same note, the inverters, like we as at Solis, we are always keeping our focus to develop a string inverter which can fit into each and every capacity. Like now, if you see the trend that higher high watt peak capacity models are very trendy. So at the same time, the string inverter is also able to cope up with that same trend. If we are not able to match the current rating of the string or PV panel, then it doesn't fit into the criteria and doesn't able to fulfill the whole overall requirement. So on this, the string inverters are now adapting that it can scale up their input current and it can able to match the latest available PV model which are coming now and even in coming in future, like even for 600 plus models are also going to be there very soon. So inverter will have the similar compatibility with those things. And talking about the internal architect and the functionality, the more or less the inverters have been adopting the same principle. The basic principle of inverter operations will remain same, but now what additional things can be added is the features and the functionality, what will going to add value to the developer, to the end client. Like having more safe operating, safe equipment to handle, like talking about the IP classification, that ingress protection capability. So we have seen that from indoor inverter to outdoor inverter, now even more ingress protection capability can able to put the inverter into very harsh climatical condition that can help us to uh, do the installation. So earlier the projects were very limited to certain criteria, but now even with having a floating solar, so inverter should able to meet that kind of environmental condition also. At the same time, the enclosure which is going to be there in future, the inverter will going to have a very high corrosion, like its anti-corrosive enclosures would be built to meet the demand, to meet the criteria to where the particular it can be fit in it. Talking about the other major concern about the inverter, which every EPC or every developer is looking for, is to have a high efficiency inverter, that best efficiency they can make out on a particular size of a system. So efficiency is already it has hit it to 99%. So every inverter manufacturer will always try to get some more innovative thing to make some addition to improve the best efficiency. So at the same for the same, that Solis has already got some adapted some new technology called discontinued PWM, which is now been very going to be there in our upcoming models, so that every the PWM philosophy is there, but the discontinued PWM, when we opt for, which can improve the efficiency by 0.5 to 0.8%. So that is another advantage, though the number is very small in talking, but when we see the overall gain in over the period of time in a years, then it can have it can quantify to a very good number of energy generations. Other few features like the PID free modules are already there, but there are some talk that an inverter should have a functionality which could able to handle the anti-PID functionality or PID recovery functionality. So inverters are now being equipped with those functionality which can able to handle the PID anti-PID functionality or PID recovery within the equipment. So no need for additional device which need to be integrated by the EPC. Another features like the arc fault circuit interruption, that AFCI is also is now been adapted, and it is very trending. See, initially this AFCI was was only required for US market, but now as those features has a very great advantage and can have more safety involved in a particular system. So inverters are now also adapting this AFCI technology to meet the more safest environment to run your solar.
Thank you, Idrish, for highlighting some of the new things that we are going to see in the inverters going forward. Let's hear it from other panelists on other technology trends. Next we have is Mr. Pavan Mathur from LONGi. Mr. Pavan, we would really like to understand from you now what will be the new module technology trends that will shape India's solar sector, and how developers are going to get the benefit of increased generation because of these better technology products vis-a-vis the aggressive tariffs also that we are seeing right now in India market. Over to you, Pavan. You are on mute, Pavan. You have to unmute.
Thank you, Jyoti, and thanks a lot for giving me a chance to speak in front of an eminent panel. I'm Pavan Mathur from LONGi Solar. LONGi is a technology-driven company. We invest heavily in R&D. So we definitely can speak more on the latest technology trends. So as we invest heavily in R&D. Roughly, if you go by the numbers, roughly we have invested $400 million in R&D till now. And we have led all the major technological revolutions that have been happening in the last few years. Be it the change from poly to mono, and then from mono to mono PERC and bifacial PERC now. So why and how we can do this technological change is because that we are one of the biggest players in the field of mono wafer. We introduced diamond saw wire cutting technology, and that helped us in reducing the kerf loss. By reducing the kerf loss, we got more wafers from the single ingot, and that helped us reduce the cost gap. Then we integrated our low-cost wafer with the PERC technology. The PERC was always there, was present maybe from 10 to 12 years. It was there in the technology front. We integrated these two technologies with our low-cost mono wafer and the PERC technology. We made a product and we pushed it with the market. We did a lot of marketing work 2 to 3 years ago, and now we can see that the whole market or the whole industry has shifted to mono PERC modules. Talking about the latest trends, there are a lot of technologies going around. Bifacial, mono PERC and bifacial PERC are the main industry workhorse these days. Bifacial definitely is going to gain steam, and we believe strongly that 2022, the market share of bifacial module is going to increase a lot. Firstly, talking about the other technologies which are going around, a lot is being spoken about the N-type technology. Now, there are 2-3 type of technologies which are being talked a lot. That is, one is TOPCon, another is HJT, and then there is IBC also. So if you talk about the TOPCon, there are a lot of benefits of TOPCon. Firstly, speaking about the N-type, we have a lot of experience of the N-type wafer, because in our wafer business, roughly 5 to 10% of a wafer we are making N-type. So, and also we have various technological groups who are working in all kind of technologies, be it HJT, be it IBC, and other TOPCon technology. So coming back to TOPCon is very easy to shift from the existing PERC lines, right? There are additional 3-4 steps, and you get better bifaciality in TOPCon. You get higher efficiency, so that eventually will give profit to the developers. Right. Talking about the HJT technology, HJT is a wonderful technology, and it will gain a lot of momentum in the coming 2 to 3 years. Right. The bifaciality of HJT is wonderful. It has no BOLID. Right. The steps are also less, but we cannot shift from the existing lines to in HJT. LONGi is simultaneously working on both the technologies, TOPCon and the HJT, and we have achieved 25.21% efficiency of cell in TOPCon and 25.26% efficiency of cell in the HJT. So these two technologies will definitely be one to look for in the coming years. Another one technology, I think IBC is there from a long time. I think the American company is making the IBC cells from a long time. IBC is a technology which has a good efficiency, no doubt a very good efficiency comes out from the IBC modules, but there are 15 to 16 steps in IBC. If you compare to PERC, it has 7. So because of all this, the IBC based modules are very costly. So I don't see IBC based modules coming in the utility segment. They will definitely be there in the rooftop segment, but I don't see them coming in the utility segment in the near future. TOPCon and HJT have the best chance. But if you have to speak for the next 2 years or the next year, I think mono PERC is going to be the industry's leading workhorse. And the bifacial is going to get steam, right? Bifacial modules, apart from India, now 80% of the utility segment uses bifacial modules. In the China, in Europe, in Middle East, 80% of the projects are using the bifacial modules. And I think India is also gaining momentum, and the developers are now very confident about this technology. This technology is not new technology. It has been proven. In 2019, 2020, people were actually taking bifacial and they were using in their pilot projects. And I think a lot of developers have utilized their bifacial test projects or pilot projects in their existing plants, and they are quite satisfied with this technology. We have always been very satisfied because we did a lot of pilot projects, and we found that if there is albedo of 20%, you can get a bifacial gain of 7 to 8%. If there is a albedo of roughly 40%, you can get a bifacial gain of 14 to 15%. We have seen in some of the cases that utilizing bifacial modules on trackers is a super win-win situation where you can get roughly 20 to 25% of gain, which is massive. But then again, you have to take care of the tracker systems. So for the next year, I strongly believe that bifacial will be utilized heavily, but monoPERC will be the main workhorse. Also, talking about the size of the module, as I said earlier, that LONGi's forte was cell. So we can actually manufacture any shape, any size of the cell. There is a particular reason why we have stopped to 182 and we have not moved further. Because we checked the entire manufacturing to deployment chain, right? We checked the module size for transportation, also from the manufacturing point of view, to the reliability point of view, to the transportation, to the O&M, to the long-term reliability, everything we checked, and we found that staying at 182 is the best decision, right? If you increase the width to 1303 mm, the deformation in the module increases by 30%. This is one of the major factors. There are a lot of factors on which we took the decision that we should not go beyond 182 mm wafer size. So we want to tell all the developers that we are not moving ahead than 182 mm wafer size. This is going to be the maximum for us. And we are constantly focusing on other technologies like TOPCon and HJT and IBC. But the main front runner is monoPERC at this moment of time, which we believe will stay for another 2 years. Thank you.
Thank you, Pavan, for sharing these insights. I think we will understand it and take developer perspective as well on the adoption trends of these bifacial. So next guest that we have is Mr. Rama Prasad from L&T. He will talk about how you've already talked a bit about how bifacials with trackers are going to lead to higher energy generation. But let Mr. Prasad share, I think he has some slides to share to talk about in detail how these trackers are going to evolve in the Indian market.
Thank you, Jyoti. I think I'm audible and my screen is visible, right?
Yes.
Thank you. Yeah, I'll take you through the presentation. So this is about the bifacial trackers. Mr. Pavan was clearly explaining that the future or the next year is fully bifacial modules and that with trackers. So I'll take you in a little bit deeper way in that. Before getting into that, the market outlook, if you see the total market now, there is a robust demand happening in the market that is 500 gigawatt by 2030. And a lot of increasing investments are expected. And this is with the support of the policies. But there are some short-term roadblocks, like we have ALMM restriction on procurement from neighboring countries, etc. And that at the same time, there is a limited capacity in the domestic module manufacturing. And of course, the important and very critical thing nowadays is the uncertainty in the module and the commodity prices. So these are the short-term roadblocks which made us to think to go beyond our present considerations in the projects. So this is how the technologies evolved in the past 6-7 years. So initially in 2014 till 2014, the projects were with thin film modules and polycrystalline modules with fixed tilt and central inverters, of course. Then keep on, it moved to different kind of module mounting structure technologies, that is with tracker, seasonal tilt, fixed tilt, etc. But in 2020, most of the projects were worked with mono line modules with fixed tilt, with string and central inverters mixed basically. And but going forward, 2022 onwards, maybe we can see bifacial modules with trackers. The reasons behind this I'll explain. If you see the LCOE optimization can happen by two things. One is by reducing the cost, second is by increasing the generation. The generation increase can happen by using the bifacial modules, because this increases the generation gain, and similarly by using the single axis trackers. So bifacial modules with single axis tracker configuration will give more increased generation. That will lead to LCOE optimization project. If you see this, the graph which depicts the generation gain or the specific gain in million units on the y-axis at various pitch of the modules, you can see the 4 lines for all the 4 combinations. The highest generation comes from the bifacial trackers. This graph. And there are some aspects which we need to keep it in our mind when we are designing the bifacial tracker plans. That is like the height of the structure, and then the second one is the GCR, that is ground coverage ratio. So if you see the energy gain with reference to the clearance height, the optimal height looks to be around 1 meter. And the ground coverage ratio will be also a very important factor to be considered in mind while designing the plant. And the second aspect is the site selection. So this is a typical study which has been done in the entire India, and for a typical 4 states are chosen to get some idea about how the generation and the bifacial grain will work out in a different states. So if you see the Rajasthan state, the bifacial gains are in the range of 25 to 45. So the gain of generation in the overall system will be around 22%. And similarly, for the places like Ladakh, you can see the generation gain of 40. So that is the best gain we can get with bifacial trackers. So the site selection also is very important for when the design of the bifacial trackers are being worked out. So the bifaciality depends on the albedo. So the tracker solutions will have to keep it in mind what kind of the soil it is. So basically based on that, the albedo will be depending. So this is for different type of soils, what will be the albedo ranges. So what we have done is that we have done various studies on how the bifacial tracker performance will be there based on the albedo, and there are some studies done. So it is advised to do some study of albedo for at least 1 period for a particular location, so that we can design the plant for a best optimal manner. So this is the enhancement albedo enhancement study which we have done in one of our test bed in Tamil Nadu by different kind of soils, different kind of materials we have used to study the albedo, then how it impacts the generation of the project. So basically the tracker attractiveness is coming through 3 points basically, that is LCOE optimization, of course, then there is a reduced module price risk if you go with the trackers by reducing the DC loading. In case of trackers, we are increasing the generation and reducing the DC loading so that the number of modules required in the project comes down. Hence the module price risk comes down. So at present, the risk of modules is very high in the market. So that can be reduced by choosing the trackers. And of course, forecasting and scheduling is another aspect which can help us in case of tracker design. But there are certain things we should look at while selection of the trackers. That is 1P, 2P kind of configuration, whether we can go with the row or row type of trackers or block type of trackers. And AMCS also compatibility is another challenge as of now. And selection of tracker vendors is also a very important aspect which we'll have to look into it. This is one of our test bed in Tamil Nadu, which gave around 28.7% gain over fixed tilt poly. This is the data which is taken for the last 1.5 years, April 22, June 2021. Thank you.
Thank you, Mr. Prasad, for summarizing so well all the trends that are evolving and how important trackers can be with respect to increasing module prices and other things. So let's hear it from Mr. Amresh Mahajan now. Mr. Amresh, maybe you can share developer perspective. You have heard from all the equipment suppliers on board what they have to say. So as a developer, what are the new trends that you are going to foresee, in terms of modules, inverters, trackers, robotic cleaning, etc.? And how are these trends going to benefit the developer vis-a-vis aggressive tender tariffs that you are seeing in India?
Thanks, Jyoti, and thanks, JMK Research. So, as you have also indicated, it's a very, very price-sensitive market in India. And I was very keenly hearing Pavan and Mr. Rama. So I agree on a couple of things. For example, bifacial is going to be the prime product in India, at least for next couple of years, unless some Topcon or HJT or IBC, or maybe after 5 years perovskite takes over. Till that time, I think the prime product will be mono or bifacial. On trackers, my point is, I agree with the data presented by Mr. Lama, but they say in India, I mean, if the model prices are going on the higher side, I mean, if the model prices are as expensive as they are these days, so then generally tracker makes sense. Otherwise, if the model prices are going downwards, then the ROI for tracker is somewhat very difficult to get. So I do not dispute what Mr. Rama is presenting, but somehow with, say, for example, bifacial modules, the albedo, if I say in Rajasthan, which is generally 27 to 30%. So the cost of tracker itself is so high. I mean, unless someone comes over and reduces the capital investment in case of trackers by at least 20 to 25%, then only it will make sense in a regular module scenario. And I mean, people will agree with me with the tariffs of say 2 rupees to 2 rupees 10 paisa. So people would have assumed the model prices of anywhere between, say, I mean, 18 to maybe 20, 21 cents or 22 cents. I keep on hearing from people, I mean, the assumptions are far lower than that, but just see it from a rational window. So if the model price assumingly on a normal market is 20 cents, then I am not sure with the kind of the capital investment and the longevity the trackers in India provide. So this is a sustainable system. So yes, if the prices of models stabilize at say 28 to 20 cents, then either this 2 rupees tariff will not be sustainable. But yes, then you can think about the trackers. So invariably, the tracker prices have to come down to make it worthwhile in the Indian market. But yes, I also agree to a point with Pavan that 182 mm is a better product suited for the Indian market because of a couple of reasons. One, he stated in his talk that the overhang is very high because of the high, the longest side. Second is the current rating goes very high, and that creates a suitability mismatch between the strings in terms of high current that is flowing through. So the entire SCB system needs to be either redesigned or someone has to look at it from a higher capital perspective in terms of the SCB and the stringing system. So 182 seems to be a better product. However, I have one suggestion for module manufacturers. I mean, Pavan is there from LONGi. So the default product of LONGi seems to be, yes, 182 but it is with a dual class system, 2 plus 2 So I am not sure. I mean, I'll be very happy if I prove if I'm proven wrong on that, but I am not very sure that it is going to be a very sustainable product in Indian market, especially with the day and high temperature difference, and secondly day temperature going beyond 50-55 degrees, because the dual glass consists of a semi-tempered glass. So both front and back side, it's a semi-tempered glass. It's a very process sensitive thing to make a semi-tempered, because in 2 thickness you cannot make a fully tempered product. So when you are putting a semi-tempered product in a Indian condition of very high temperature of say 50-55 degrees centigrade, so if it sustains, I'll be very happy, but I am not very optimistic on this front. So as he rightly said, they invested a lot in R&D. They've put $400 million. They should also think from a fully tempered glass with a transparent backsheet type of product. I tried to reach out to certain players with this kind of combination that is more suited towards the Indian market, but I mean, there are very few who are thinking on that line, but my understanding is that is going to be a better product for Indian market rather than this glass to glass. So these are a couple of couple of things which we are looking at from future projects, at least for the 2 to 3 years window. 182 bifacial. If the prices are in a reasonable range for modules, then it will be without trackers. If prices go high, but then I mean it has to justify the tariff also. So or if the tracker prices come down by say 20%, or I mean to that rational level, technically it is a very it's a better product. So we would like to go with trackers unless the ROI makes sense. But I would like to manufacturers like LONGi and few others to look into this possibility of making it a glass to backsheet product. And after 3 years, yes, the journey will move towards, my own understanding is it will be till 3 years it will be more or less a bifacial product. Then afterwards it's either TOPCon or rigidity, and post 5 years it will be perovskite all the way. So that is my understanding on the market. Thanks, Jyoti.
Thank you, Amresh, for giving your critical views on the topic in hand. I am going to come up with questions on price trends that are expected from the equipment suppliers that are there on the panel today. But let's hear it from our last panelist on board, from Mr. Samanta. Mr. Samanta, you have heard what other panelists have to say. Specifically for you, I wanted to talk about in this evolving technology trends and other things. What do you think, in terms of domestic manufacturers, what role they are going to play? Specifically, with the new PLI scheme in place, do you think the Indian developers, Indian manufacturers will be competitive with the global counterparts? Over to you, Mr. Samanta.
Thank you, Jyoti. Thank you, DMK Research. Okay, first of all, I'll talk about the PLI and where India is going for the Atmanirbhar Bharat. Right? If you look into the overall PLI scheme, which has been drafted by the MNRE, and they have called for tender as well. So there are different objectives. First of all, high efficiency and high volume production, number one. Number two is that there will be a cutting edge technologies, in a sense, like it's not only that the high efficiency, but also you have to look into the temperature coefficient and the other factors. The next thing that is that a ecosystem that to be developed with an integrated manufacturing facilities, in a sense, like it's not only that right from the, we know the stage 1 is the polysilicon, stage 2 is that wafer, I mean with the ingot, stage 3 is that cell, stage 4 is the module. But we have developed a kind of an ecosystems in India, where still it's lacking like 3 to 5 gigawatt level of BOM and the other systems are there. Yeah. Next level, we have a huge opportunity for employment, in a sense, like, it's not a direct employment that the manufacturing guy, maybe, if it is a 1 and maybe 10 times indirectly, it will give an employment opportunity with all the BOS and the BOM components, right? If you look into the very detailed analysis on the PLI, so there is a 2 factor. One is the efficiency is above 19.5%. Even 19.5% may not be qualifying. You have to go beyond maybe 21 and 22. So which clearly indicates that we have to look into the technology. So today's technology with the P-type monopark may be sustainable for 1 and 2 years, but to have a longer durations, like we have to go with the N-type material. If we go for N-type material, definitely the new technology trend is coming, whether it is top born or it may be AGT or other technologies. If you look, the other factor as well is called a temperature coefficient. That is also a part of these factors, So the temperature coefficient today with the P-type monopark is 0.35 per degree Celsius per cell, right? So way forwards with the N-type, definitely this is given an advantage indirectly, like 0.28 or 0.26. But it's not only on the silicon material, but there is also other technologies, say, for example, cadmium telluride as well, So in the value chain, it's not only the silicon, but also there is other technologies like cadmium telluride or CIGS will be in place. So we know there was a first bidding process which ends in the 20th of September, and we had seen that huge response, maybe around 54 gigawatt level of manufacturing facilities, but all may not be in a stage 1, stage 2, stage 3, stage 4. But stage 4 is only module manufacturing. So as far as India is concerned, so today we are sitting a little bit in a difficult situations, in a sense, like we do not have our control on the polysilicon. But if you look at the last year, the polysilicon was almost $10 a kilo, and today it is going beyond $42 a kilo. Now the question is, how this thing happens. In India, there is no polysilicon. So in China, there is a polysilicon. But if you see the power intensives is a polysilicon. The polysilicon, which is, maybe around 45% of the power it takes. But in China, only 12% increase in the power cost. So where is the other money? So there is something happening in the value chain which is beyond of our control. So what I want to say from the Indian perspectives, we had seen the initiative taken by some of the companies before PLI as well. They are before successful the bidding on the PLI. They have acquired some of the polysilicon companies, some of the high efficiency cell manufacturing company, some of the wafer manufacturing companies, some of the EPC manufacturing companies. So what I want to say from the initiative point of view, all the majors, all the big corporate, and we had seen even the successful PLI in the L1, L2, L3. L1 is your Jindal, L2 is your Surety, and L3 is the Reliance, and L4 is Adani. But we have allocations of 4,500 crores which has been passed by the cabinet. But this may not be sufficient. We need an additional maybe 6,000 to 700 crores, which is to be dispersed. But in this process, we know the process, like it is a tap out 1.4, 1.21, 0.8, and 0.6 and all. But there is also a complex situation, complex matrix, means the domestic content will also be there to capture, these incentives, the PLI incentives. So what I want to say, as on date, things are in place, but there is a time, like, from stage 1 to stage 4, it takes 4 years time, right? So we have to, we had seen earlier, and we have seen now the initiative things are in place, and I am sure that India will be a highly competitive manufacturing. It's not only catered to the domestic, but also export as well. But as far as the technology is concerned, I can discuss as well, I mean, what we need, from the developer's perspective, maybe in a later stage, Jyoti, right? Thank you.
Thank you, Mr. Samanta, for sharing your viewpoints. Let's have a quick round of questions that I had with me. So my first question is for Pavan, if you can probably answer some of the comments and remarks that are being raised by Mr. Mahajan here. But I also wanted to understand from you, what are the implications on the global suppliers with respect to the new ALMM and BCD implication?
Look, we are watching all these implications very closely. The BCD coming from 1st April 2022, definitely they will make impact, and that might push the outside players to start manufacturing here. But that cannot be the only thing. If the government wants the players to start manufacturing in India, it has to be many more things actually. It is module manufacturing is a costly affair, right? So a lot of, if we start module manufacturing here, we need a strong policy from the government, a strong and a stable policy from the government. Just by increasing BCD, let's take an example. If the government increases the BCD and let we start manufacturing here in India, right? But will we be able to have an ample amount of manufacturing in India? Let's suppose we start manufacturing, we start setting our plant here now, and 10-12 months down the lane, we have a plant in India. We start manufacturing, right? First of all, it has to be a lot of other things too, because we need manufacturing of the cells, the glass and other things to be with us. Another thing is, if we start manufacturing in India and 10-12 months down the lane, we have a product, will that be able to suffice the need that India has? Because, if we go by the requirement of India, like we have set the target of 450 gigawatt 2030. And so that means that we need 20-30 gigawatt every year, right? Even if we start manufacturing in India, at the end of the year, there'll be ample gap between what we are manufacturing and what India needs. So if the government goes back and dilutes the BCD and again the Chinese product becomes easier, what will happen to us who have started manufacturing, right? So what we need from the government is a strong and a stable policy, and otherwise and that will help us in taking decision in manufacturing in India.
Right, Pavan. Let's hear it from Mr. Amresh. We have seen that there are certain project delays in last few months because of this ALMM issue. Some players are not able to get it listed. So what impact it will have on the project developers? My first question. And my second question is, with the domestic manufacturers scaling up their manufacturing plants in India, there are many new players who are going to enter. Will tier 1 developers like O2 Power will be exploring domestic modules as part of their large scale installations?
So from a long-term perspective, yes, we welcome Make in India strategy, and yes, we'll be exploring the local manufacturing, and we are already in the process. In fact, we at O2 Power, so we were one of the first movers to explore. And see, yes, for a shorter term, I mean, there'll be some hiccups, there'll be some teething problems, and if some benefits are given in terms of timelines for duty or grandfathering or whatever. So all these steps are welcome, but everyone knows that over a period of time, if country has to sustain, so it has to sustain from all quarters, be it manufacturing, be it local content, be it use of renewable over a period of time. So the vision is that yes, we hit the renewable targets. We hit at a run rate of say 25 to 30 gigawatts per year and accelerating in the years to come. Simultaneously, we also keep on developing the local manufacturing, not only in modules, in terms of cells, in terms of wafers, ingots, and everyone. And that is why the PLI scheme is. And maybe after a couple of years, we are just sustainable. Say, for example, if only we hop in one direction and rest of the supply chain doesn't follow up, then there'll be a point, then there'll be some mismatching issues. So in the larger interest of nation, so we are with Make in India, and we are maneuvering ourselves. We are strategically trying to do tie up with the local manufacturers. We are trying to explore the local manufacturing, and yes, we'll be following that, bearing the few initial hiccups. Now, your second point is, how do we see the Indian developers, Indian local manufacturing getting developed? So I was speaking to some other forum, a couple of weeks back. My own understanding is, and I've spent reasonable good amount of time with the manufacturers also, the quality of Indian product was never in question. So I think I'm seeing manufacturing happening in India from 2008 onwards. It was never in question. The Indian made modules, they have spent around 13, 14, 15 and few plants, 18 years also in field. And they are as good as the performance of earlier the European made modules, and after that the Chinese made modules. So the quality was never a question mark. The question mark was twofold. Number one, the quantity, and second, the backward supply chain. Now with high efficiency cells coming up, so what happened was, even the equipment cost used to be very high. So for a 200 megawatt line, the capex was so high that even if someone wanted to, a middle scale player, they could not afford it to go beyond 200 or 150 megawatts. But the capex of module line these days is, I think, all-time low, and the cell efficiencies are high. So for a 530 watt module, or someone are making 600 watt module, so very easily with a very low capex, you can make 801 gigawatt line. And luckily this Make in India scheme has coincided with the phasing out of the earlier product that was 156, 157 mm. So you can no longer make a module in that line. So either you take an exit from the business, say goodbye, or you invest in new lines. And when you are investing in new lines, you cannot, with the kind of capex, you'll never want to go for 200, 300 megawatts. That will not make a business sense. So invariably, all the Indian manufacturers who are having 50 megawatt, 100 megawatt, 150 megawatt, they are sort of abandoning their lines, earlier lines, and they're investing in minimum 700 megawatt and going forward 1 gigawatt, 1.5 gigawatt. So it has helped two folds. Number one, the Indian model capacity has increased. And secondly, since they're getting new lines, so they are clubbed with all the automation that is available in the market. So as far as I see, these all are state-of-the-art lines and as good as the line on which modules are made in China. And quality was never an issue. So invariably, the infrastructure of module at least is very good in India. Cell lines, yes, generally there was a lag. Say when the Indian module capacity was 10 to 12 gigawatts, cell line used to be 2 to 3 gigawatts. I am hoping that similarly, since the capex of cell lines is also going down and people show more interest, and with the BCD coming on cell lines as 25%, so this delta of 4 gigawatt and 15 gigawatts, so there was 11 gigawatt delta, so that will be replenished, that will be reduced. The delta will still be there because still the cell line capex is high, but over a period of time, I think this will also be neutralized. The catch is where Mr. Samanta also touched on, the PLI, and if we are able to integrate the entire backward supply chain with the cell and module over a period of maybe 3 to 4 years, then I don't think we have to look beyond India for our consumption. So I am hopeful, and more than hopeful on manufacturing. I am pretty certain that we'll follow all the quality standards which are prevalent in the manufacturing industry. So that is my point of view.
Thank you, Mr. Amresh. Those are very valid points, I must say. And in short term, if I ask you, like there is an issue with ALMM and there are many projects at aggressive tariffs of 2.5, for which equipment procurement will start by next year. So what do you think, what is your take on that? Do you think that that issue is going to be resolved anytime soon, or is there any alternate ways the developers are looking at?
See, in my view, it is the uncertainty that kills the business. It is not, your assumptions may go haywire, but it is more when you are more uncertain. So assumingly, if people have bidded on a lower tariff after the BCD was announced, so they have done it consciously. I'm sorry. They have done it consciously. So the only challenge will be, in case the model price, they do not come down as per their assumptions, or if they have taken very abrupt assumptions, then only it is going to impact. But if people who have done some rational maths, keeping in view the forward-looking price with the curves which the market has seen over the last 10-15 years, of course you can go wrong on anything, but still, if people knowingly what is coming up after 1st of April and rationally, studying the market, if they have done their homework, then I do not see any reason of discomfort unless the entire, market goes for a toss for everyone. But there are only two ways if, the projects can backfire. Number one, if the assumptions were very, very uncertain, the assumptions which people have done. So basically, they're done just to acquire the projects and they have not done their homework properly. Or if this uncertainty on the module pricing, which we have seen in last couple of months or couple of quarters, remains in the market for, say, next 1 to 2 years, then it will be issue. But I'm hopeful things will settle down for good, and the players who have done their homework, so it will not be any problem for them. So that is our view.
Thank you, Amresh. Let's hear it from Pavan and Idrish also on the price forecast. I know it's a little tricky question, but if some range do you think, what are the price forecasts that you are also exploring the global trends as well? So in next 1 to 2 years, Pavan, for you, what are the prices for India market for mono PERC as well as bifacial modules? Any numbers, any range you want to put there?
Jyoti, you very rightly mentioned that's a tricky question. Price depends on a lot of things. The recent price increase was also because of sudden things, actually, unpredictable things. So in the next year, I really can't predict that what's going to happen, what new policy is going to come, and what sort of an impact it's going to make on the prices. So I'd refrain myself from commenting on that the prices will go up or down. I really can't predict, because nobody could predict the recent surge also. So I'll stay away from this question.
Okay, I thought there are some forward-looking statements that module suppliers do issue. So this is that some percentage. Nonetheless, Idrish, you have anything to comment on that, specifically from an inverter perspective? Do you think the prices are going to be stable, or?
It will be a little other way around. Like, see, already semiconductor industry has badly hit it in 2020, and a lot of supply chains are affected due to that. And we have seen a decline in manufacturing capacity of solar inverters due to this supply chain issue of semiconductors. At the same time, even this will going to continue in next year as well. And looking at the market demand and other challenges like logistic issues, the freight charges are also being increased a lot. Hopefully it is going to be get settled down, but it doesn't see very quickly it will going to happen. So there will be a slight change in the market, in the prices also. Like yes, the solar inverters are always are been been not so expensive than the solar module, but yes, it also contributed to the overall project capacity. So there will be a slight change in the price, but it will going to be, if the things will going to be get settled down by the raw material side, then then overall benefit can be transferred further to the end customers.
Thank you, Idrish. There is one important point that we've missed, which is on the robotic cleaning and improved O&M practice. So I want to keep that as an open question. Anyone who would like to talk about this, maybe Mr. Prasad, you, or Mr. Samanta, you. Do you think robotic cleaning will be the new trend that going to be uptake in India?
Yes, I think, thank you, Jyoti. I think we had witnessed with the water cleaning. As you know, we have to save the Mother Earth, So roughly I will give the numbers, like every megawatt we spent about 5,000 to 6,000 liters of water. And it's not only this water has to be, the iron removed. So in a sense, like it's a treated water. So every water is very, very costly, and way forwards, I believe that, robotic based cleaning is the ultimate solutions. But when you install a system, yes, a little bit capex is a little high, because in a water cleaning systems, what you do normally, we give a outside contract, for water cleaning, and depending on the, kind of a cleanings, like monthly, thrice the cleaning, 10-day cycles, and also a per module cleaning, that we cost, how much passive it costs, right? But the factors that the losing what is that because of the swelling, some of the cleaning process is not as perfect, particularly on the edges of the aluminum frame, So robotic cleaning is definitely is a much better, and you have a enough frequency that depending on your your monitoring items, in a sense, like how much is the swelling, so you can enhance your cleaning cycle. But the best practices is that every 3 months you should have a wet cleaning process with the dry cleanings. That's best recommended. This is about the monofacial, and on the rear side, yes, 6 months you should clean for the bifacial module. So that's the kind of the fundamental understanding from the O&M perspectives. Thank you.
Thank you, Mr. Goutam. Mr. Prasad, do you have anything to add on this in general on the O&M practices?
I just wanted to add one point to Mr. what Samanta is explaining. See, the main reason for the success of the robotic cleaning going to be is the scale of the projects. We were talking 10 megawatt, 20 megawatt size of projects way back 2012, 13, those periods. But people are talking now everything gigawatts. So when the project scale goes up, then you have the serious issue of the resources, whether it is water or manpower for cleaning. So the robotic cleaning is the ultimate solution for that. So now when the size of the projects are getting increased day by day, the utility scale, so the robotic cleaning will make a very, very good, big sense.
Thank you, Mr. Prasad. Let's take some last set of questions from our audience here. These are the open questions. Anyone who has answer can respond, please. What will be the status of polycell price trends for next year?
Polysilicon, poly means multi cells. He's asking
Yes.
something. Okay, see, basically what happens, polysilicon materials itself is very, very rare. I mean, if you look into the resources on the ingots, basically, you see, right after the polysilicon is made, either Siemens process or fluidized reactor, mostly it is going now with the CZ Joukowski's method, where they put with the monocrystalline in materials, So what I will say, it will be hardly 3 to 4% or 5%. I mean, that too also, it's very difficult in a sense. There are two things. First of all, the amount of efficiency what you are getting with the poly is a limited, like 18 to 19% on the higher side. So vis-a-vis if you do in the mono, so you get a 21%. So what I mean that from the same footprint, you get a more and more generation. So therefore, I believe it's very, very difficult. 2 to 3%. Suppliers will be very limited, and that too also getting a source of the wafer itself will be very, very difficult in the future.
Thank you, Mr. Goutam. The next question we have is there scope for new entrants with 100 to 200 megawatt module assembly lines?
No, not feasible at all. So today the bottom line is, I can tell you there are different wafer format, like, M6 is 160 by 160, and then M10 and the M12, So the bottom line with the M6, where you can utilize a 450 megawatt, a single line, right? And if you use it with the M12, you can reach maybe around 580 megawatt. And if you use it M10 in a better utilization, you can go beyond 620 megawatt. So the minimum bottom line with the automated, right from the glass loading and auto bussings, everything is, is automations is a, what I will say, 600 megawatt, I mean, things. So that is the industry trend. And it's not only that, but Amresh has also mentioned that, see, with the volume, we have to see into the capex as well. I mean, module manufacturing is not a high technology job, but also low risk and high profit making. Low risk, what I want to say, most of the property of the cell, which is coming from the cell manufacturing, either LID, PID, LETID, and all, from the module manufacturing point of view, you have to ensure that couple of process steps that you do it. And I believe that in India, there are enough quality and people are doing that one. So to get a maximum profit, you should have a line with the high volume and with the low risk, I'll say, and high profit in the module.
Right, Mr. Goutam. Last two questions I'm taking. This is from Mr. Bekunt from Vikram Solar. Your opinion on higher wattage modules greater than 700 watt peak?
Unless you can share some of your.
Yeah, so I think, 700 watt peak, see, it is a reality actually, maybe after a year or so. So, but issue is not that, you want to create a record by making a 700 watt module. It is more about the efficiency of the cell and the stability of the module in the field. You can make a very big module. So like, as Pavan said, so they are limiting themselves to 182 mm wafers, but there are a lot of players and especially one of their competitors. So, they are projecting 210 mm and market is ripe. Actually, the equipment which we are seeing, they are actually compatible for 221 mm also wafer size. So when you're making 221 mm wafers and you increase the efficiency just one notch up by say 1.5%, which is a very high likelihood, there is no way you cannot see a 700 watt module in near future. But the problem is whether it is meant for India. Secondly, whether the mass scale production is possible, and if possible, when and how it will be ramped up. And third most important aspect, I think Pavan touched on that, the transportation is a very, very high cost expensive, and especially people have realized a couple of months back when the container price touched, I think $10,000 per container, 30 feet high cube, 40 feet high cube container. So you want to use the maximum volume of the container. In poly, people touched around 92% also. They put modules on 92%, just 8% of the space was not utilized. I understand, again, in 182 mm, it is very optimized. But if, say, for example, 221 mm makes a 700 watt module, but you are able to utilize only, say, 70% of the container space, then the cost will be passed on to the final customer. So it's not about creating records about the cells, wattage, or the efficiencies. Efficiency, yes, but cells, wattage, or the size. It is about making a most optimal product in a very, very price sensitive market in India.
Thank you, Amresh. Pavan, you have anything to add on to this?
Yes,
point?
I think Amresh sir has mentioned and touched every point. But if I have to mention, if I have to summarize the thing about the larger modules, the reliability takes a hit. Is the reliability. It's not manufacturing a module with bigger and bigger wattage. The module has to live a life of 25 years or 30 years in case of bifacial modules. So people should not forget that it is not the manufacturing of modules, it is the life of the module. When we talk to developers, we talk so much about the bankability of a module player. So same is with the reliability of the module. The module has to be very reliable. As sir touched upon that, it has to be transported. It has to be installed. And people at site they may not be handle it properly. If they may not be able to handle it properly, there can be a lot of breakages during O&M, breakages during the life of the module. So in short, reliability takes a hit. So as sir mentioned, it's not the size of the module only.
Okay,
Right.
I want to point out, if you look into this, the 700 modules and at what configurations, right? Either it may be M10 or M12 wafer, but M12 is most likely, If you see there, the number of cells will be 156. So 21 by 21 into, say, bottom line is 21% efficiency. It gives 9.2 watt, right? So as far as the area efficiency is concerned, you are not improving the area efficiency. Or in the other hands, what happens, if you look into the in the quality perspectives, what we call the total quality management. As far as the factory is concerned, there is no doubt on that. But during the transportations and especially during unloading, during loading, it is fine, in the factory, but during unloading at the site and also when you are putting into the table in the systems is very, very important, So in terms of the square area, something like, the width is 1310 and the length is 2.8 meter. You understand? I mean, if two people handling of weight is 42 kilo weight modules, I'm talking about, this is bifacial, but monofacial may be like slightly less, 37 kilos, right? So what is that handling? The second thing is that India, there is a prone towards the climatic condition. You have seen that now the twice a cyclone in the coastal areas, either in the east and the west coast or the east coast, So the wind channel effect has to be done very thoroughly, in a sense like today's structures, what we do is a best like 25 to 28 ton per megawatt. So we have to be careful when you are putting something like, 36, 37 kilo a kind of a modules here. But yes, you can calculate in terms of your the wattage, as well as there is a beneficial in terms of the structure as well as cable cost. But also you have to look into the things like for the high velocity, a high wind velocity, something like if above 100 kilometer per hour, So today we are fixing with the 4 point, where during our installations, So if the length is 2.8 meters, so what happens if it's a 100 kilometers per hour or beyond, it will be acting as a cantilevers, I mean, like only 4 points you have, and there is an upward thrust. So there is a more and more breakage of the, the longer the cells, like 210 millimeter. So the chance of the creating a micro crack more is not only because of the handling, but also because of the climatic conditions. Thank you.
Right, Mr. Goutam. My next question is, I think probably Idrish, if you can answer it, is what is the cost increase? We have seen that a lot of utility scale plants and larger scale plants are also shifting towards string inverters now. So is there any cost increase? What are the benefits of string versus central? Do you think this trend is going to go to be continued in next 2 years?
Yes, because see, this string has already been proven in the market now, and why it has been started opting is there are many various reasons like ease of O&M activity, ease of installation, plus availability guarantee. So when we do the cost comparison between central and string, we can't just only consider the inverter as a component and price comparison can be done. But when we look into the overall picture, we have to consider all aspect like balance of system, how much capability, because the string inverters are now coming up with multi-MPPT functionality, which can anyhow it can give you like 0.2 to like 2 to 3% gain. You can get it from the particular inverter because all the models which are going to be there in the field are not identical. So your mismatch loss has been completely rolled out when the string inverters are off. Plus, then you have a better generation guarantee. Plus, the O&M activity become easier if any breakdown happens. So you don't require any skilled manpower to deal with that. You can just simply take out the broken one and replace it with the new one. So when we do the overall cost comparison, string always gives you better result for a longer period of time. So if you just compare the initial capex comparison, yes, central inverter will give you a better picture. But when we look into the long-term perspective, string inverter will always give you a better result in terms of higher generation yield and ROI.
Thank you, Idrish, for sharing your comments. And I think with this, we would like to wrap up this session. Thank you to our panelists today for sharing such wonderful, informative insights. Special thanks to LONGi and Solis for supporting us for this session. The recording of the session will be available on our website shortly. Have a good day. Thank you.
Thank you.
Thank you.
Thanks,
Thank you,
thanks
everyone.
Thank you,
everyone.
everyone.
Thank you.
Thanks a lot.
Bye.